Hello everyone, so now we are going to do the Eigrp metric. I hope you remember we done OSPF metric calculation also. Like that we have different formula to calculate the Eigrp metric. So this is very important. In interview you will get many questions from here also. So you need to remember Eigrp use the metric to select the best route. Same like in the OSPF. OSPF is also using the metric to select the best route from the available routes to go to the destination. But here in Eigrp we have the 5 component. In Eigrp we have the 5 component. One is bandwidth. First one is bandwidth. Second is load. Third one is delay. Fourth one is reliability. Fifth one is MTU. Maximum transmission unit. How much maximum the interface can transmit. We will see how we can check this all. But in the calculation we will use only first one and third one, bandwidth and the delay. By default only these two we are going to use when we are calculating the metric. By default Eigrp is going to use only bandwidth and delay to calculate the metric. But we need to remember in interview if anyone asks you what is the Eigrp metric, you need to tell Eigrp metric is used to select the best path to go to the destination. And you have the 5 component, that is K1, K2, K3, K4, K5. They will ask you what is K1 means, you need to tell bandwidth. K2 means load. K3 means delay. K4 means reliability. K5 means MTU. So we will see this one in detail. We will see now. So if you want to check this K value, how we can check? We need to write show IP protocol. So you will get here the K value. If you see here, by default they are using K1. How I am saying the K1? Because here if you see K1 is equal to 1, K2 is equal to 0. So he is not using this one. K3 is equal to 1. This one is using. K4 is equal to 0. This one is not using. K5 is equal to 0. This one is not using. So here for calculation, here by default we are using K1 and K3. These two only we are using. By default all Cisco router is using only these two. Okay, so now what we are saying, K1 is a bandwidth. Eigrp pick the lowest bandwidth from all outgoing interface of a router to the destination. Outgoing interface, if you see here, I need to say outgoing interface means this one. If you see, let me show you if we have any diagram here. This one, if I go from here like this way, okay, if I am going from here to here, outgoing interface. So this is the outgoing, this one, because my traffic is going into the router and now leaving the router. So outgoing, this one, and this is the into. So we will not consider. Outgoing means this one. So I need to check this bandwidth and this bandwidth. Okay, I will show you that one, no problem. Just I am saying, I am showing you with this point. Let me read that point again to explain that one. What I am saying, K1, Eigrp pick low bandwidth, lowest bandwidth from all outgoing interface of the route to destination network. In simple, we need to look the low bandwidth interface. We need to look the where we have the low bandwidth of the all interface, whichever is going from the source to destination. We will do one lab here. We will do one calculation here, so you will understand here. Okay, so no need to worry. Just remember this one, bandwidth is the amount of data that can be transmitted in a fixed amount of time. This is a definition of bandwidth. What is the bandwidth? Bandwidth is the amount of data that can be transmitted in a fixed amount of time. And now in formula, if I want to get the K value, I need to check lowest bandwidth from all outgoing interface from source to destination. Then we have K2, but we are not using K2 because K2 is always dynamic value, it is changing. That is load. Load is dynamic value that change frequently. So we are not using. By default, Cisco is not using K2 value in metric calculation because it is not a stable. It is always changing. Load is always changing. If it is changing, automatically it will flap the traffic. It will move from one interface to another interface. It will not stable. We will have the flapping from one interface to another interface. That's why Eigrp is not using the K2 value. It is the, what we can say, load is a dynamic value that change frequently. It is based upon the packet rate and bandwidth of the interface. So it is changing depending upon the packet rate and the bandwidth of the interface. It calculates the volume of a traffic passing through the interface in comparing of the maximum capacity. It expressed in the scale of 255, where 1 represent the interface is empty, and if we have 255 we can represent fully utilized. Means we have the value. If 1 is there, means we can say no traffic, that is empty, interface is empty, no load in the interface if we have the value 1. If we have the value 255, we can say interface is fully loaded. Okay, single data flow from the board direction. Router maintain two separate metric count, that is TX load for outgoing traffic, RX load for the incoming traffic. What I want to say here, whenever data is going from one interface, let me draw here. Example, I have one router here, I have another router here, and data is going this way and also data is coming this way. So we will have two TX load for the outgoing traffic, RX load for the incoming traffic, whatever traffic is coming. Whatever traffic is going, that is a TX load. Whatever traffic is coming, that is a RX load. But this one we are not going to use in the calculation. But just for your knowledge, you need to know, because someone, if asks you someone why we are not using the K2 in the calculation, by default Eigrp will not use K2. Why it is not using? Because it is having the dynamic value that is changing frequently. Because of that one, the route will be flipped, means move from one interface to another interface from the routing table. So the because this is changing, it is not always constant value, it is changing based upon the packet rate and the bandwidth of the interface. So that's why it is not using in the calculation, and we are using the K3. K3 is nothing but delay. We need to remember, because K1 is bandwidth, we need to remember like this: K1 is bandwidth, K2 is load, K3 is delay. Delay reflect the time take by a packet in crossing the interface. It is measured in the fraction of second. So we will see that delay also. Delay, if you see here, this is a delay. If you want to check for any interface, we can write show interface and interface number, example E0/0. So you will get what is the MTU, maximum transmission unit, how much maximum transmission whatever we can send. By default we have 1500 only, and bandwidth, this is a 10,000 kbps, and delay is 1000 microsecond. And if you see, reliability is 255, TX load is 1/255, and RX load is 1/255. So this one delay here you can see, this is a delay. Okay, and after that we have the K reliability, that is K4. What we can say, this value also dynamic, just like a load, reliability is also dynamic value. And it compare all the successfully received frame against all send frame. Means what we can say, it compare all successful receive frame against all receive frame. Like if you have one router here, he is receiving some frame, so he will check whatever the successfully receive, whatever you receive, he will compare what is good, what is having some errors, he will check that one. Depending upon that one, he will change the value of the K4. So that's why we are not using K4 also in the calculation. So what I can say here, 100% reliability indicate that all the frame which we receive are very good. Means here what I am doing here with this K4, we are just comparing. I receive 5 frame, okay, I will check all 5 are good. If all 5 are good, we can say 100% reliability. If we have some error, some issue in the frame, maybe we receive 5 but we have good frame as 4, so this value again change. That's why this one also not include in the calculation. And we do not have any issue. If we receive the 100%, then we can say we do not have any issue with the physical link. And if we have any issue with the physical link, this value will be decreased. Example, if you receive 5 but 4 or 3 is good and remaining 2 is not good, then we can say we have some issue with the physical link. Maybe this link is coming up and going down, coming up and going down. That's why it is decreasing. So we will not use in the calculation this one also. And after that we will have the MTU. MTU stands for maximum transmission unit. it is advertised with the routing update, but it does not actively participate in the metric calculation. This one 1500 maximum transmission unit. So this one also not used in that one in the calculation. AS we already know, where we can see AS. I think here somewhere we saw autonomous. Let me show you here or this one. So this AS is nothing but autonomous system number. So same thing I mentioned here. Let me show you. AS is autonomous system number. Eigrp share the routing information only with neighbor if they have the same AS number. If you see here, I have the R1 and here I have the R2, and this guy is having the AS as 1 and this guy is having AS as 2, then they will not form as a neighbor. They should have the same AS. So in order to become a neighbor, AS number must be matched. This number should be same as this number. AS create a logical boundary for the routing information. By default, router will not propagate to route information outside the AS number. If you use different AS number here, it will not propagate, it will not send the information. In the Eigrp, you need to have the AS number should be same both the side. So this is just about the K values. So now we will look the metric, how we can calculate the metric, path metric calculation. So this is a formula. This formula is important. Eigrp metric is nothing but 256 into 10 to power of 7 divided by minimum bandwidth plus delay. Okay, this is a formula. So what I can say, I can define here. I am saying that if you want to calculate the Eigrp metric, we need to write 256 multiply 10 to power of 7 divided by minimum bandwidth, then sum of interface delay divided by 10. Okay, this is a formula. We need to remember this formula. Now we will do here. So what we will do here, let me show you. Let me use the same lab, this lab only, to calculate that one, the one which we done. Here I wrote this lab. So let me show you what we are doing here. In R1 we write show IP root Eigrp. We write show IP root Eigrp. We get this number 409600. Okay, this number we get, and we are saying this is a metric. Okay, this is the AD value, this is a metric, as we discussed before. This is a AD value, this is a metric. So now we need to check how we can get this number. So how we will get this number? If you go here in the R1, first we will write show interface E 0 by 0. So here you will get the bandwidth and delay, and this is our R2. In the R2 we have the loopback 0. Why I am checking loopback 0? If you remember in our formula what I told here, the outgoing interface. If you see here, let me show you where I mention. Eigrp pick the lowest bandwidth from all outgoing interface of the router to the destination. So this point we need to check. So for that one, what I am doing, I am using this topology. I am checking if I am going from here to here like this way. I need to check the outgoing interface bandwidth. So this interface bandwidth and this interface, the loopback 0 interface bandwidth. So this bandwidth I need to check which one is having the here you see, let me show you this definition again. Lowest one, which one is having the lowest one, we are going to pick that one. But the key point here is outgoing interface and the lowest one. These two things we need to remember. So if you see here, we can calculate the value. We can check the value. How we can check? Just go inside the R1 and write show interface E 0 by 0. You will get the bandwidth and the delay. And if you go in the loopback also, R2 loopback 0, you can write show interface loopback 0. You will get the bandwidth and the delay. As per our theory, what they are asking? They are asking minimum bandwidth. So who is having less bandwidth? R1 is having less bandwidth, that is 10,000 kbps. If you go, this is 80, big value. So we need to take minimum bandwidth. So for that purpose, what we done here, this is a 10 to power of 7 and this is a minimum bandwidth. This is a sum of the interface delay divided by 10. So this remains same till here is same. This is a minimum bandwidth, this is a high, so we will not take this one, we will take R1. So this is a R1 value here, this one. So we take this one, 10,000. So we write that value here, 10,000 value we will write here, this one 10,000. And after that, sum of the interface delay. So whatever the interface, if you see, we have the 5,000 here, and if you see here what we have, 1,000 here. So 1,000 plus 5,000, we will write 1,000, 5,000. We will add this one as per this formula and divide by 10. So if you add this one, this is a 1,000, or this is a 5,000, and let me check, maybe I wrote here wrong. This is 1,000 and 5,000 here. So this should be delay. I am taking 1 minute. It should be 10,000. I wrote 10,000. Maybe I taken the wrong screenshot here. We will do here anyhow. We will add here. So when we add here, we will get one value, and we will divide by 10, and we will add this number, and we will add this 2, then we will multiply. So whatever number we will get, this number and this number will be match here. This number 409600. If you see here what number we are getting, 409600. Okay, so now we will do this calculation, so you will have idea, because this one I done before, so maybe I put the wrong key screenshot here. Anyhow, we will verify now. So this one is a sum of the interface delay divided by 10. Sum of the interface delay divided by 10. So let's do here lab. So what I will do here, I need to get the information. So let me move this here. We need to go from here. We need to go from here to here like this way. So this interface and this interface we will check, whoever is having the minimum bandwidth. Whoever is having the minimum bandwidth. So what we will do, minimum bandwidth means this one bandwidth and this one bandwidth we will compare. So what I will do, I will go here in the interface fast Ethernet 0 by 0. First R1 I will go enable show interface F0 by 0. So interface F0 by 0. If you see here, what is the bandwidth I am getting here, this one. Okay, so I will take this bandwidth. Let me write here somewhere in the notepad or somewhere, maybe here, bandwidth. Let me write the bandwidth formula first of all. So let me copy. So this is our formula. So what I will do, minimum bandwidth. So if I check here, what is the bandwidth here, this one, and let me paste somewhere. Let me paste here only. Here I get this one. And now I will go to R2 and I will check the bandwidth for the loopback interface. Let me go show interface loopback 0, and if you see here, this is the bandwidth for this one. So I will go here and I will paste this bandwidth here. Let me increase this as a 15 and this is a bold. So this is the bandwidth we get as per our formula, what we told, minimum bandwidth. So let me copy and paste the same thing. Okay, so if you see here, this value will change here. What will be the minimum bandwidth? If we compare from here, this will be minimum. So I will copy this bandwidth. I will copy this bandwidth. I will put that one here in this place. Okay, now some of the interface delay. So we need to look this interface, this interface, this interface. We will check the interface delay. So I will go here. What is the interface delay? Here we have, this is the 100. Okay, and in here 100. So let me write here 100. and let me check in the R2. Show here also we have delay. This is 500. Let me write here this one. And let me check this one is the 5000, I think. I will check fast Ethernet 0x0. So here I will go interface fast Ethernet 0x0. Okay, so now here we have the 100 microsecond. This is bold here. Okay, so now we have this value. And if we see some of the interface delay, so we will check here. First of all, let me check this, how many, 1 2 3 4 5. So I can delete 50 here. 1 2 3 4 5. So we will have 100 here. Okay, if I see 1 2 3 4 5 here, 1 2 3 4 5 means 100. So 100 will remain here. So let me move this next line. And I will make this as a 100 only, this one. And here what value we will have here, some of the interface delay we will have. Let me write here, as per our theory, what we have here, sum of the interface delay. Let me check here delay, what we write, delay reflect the time taken. This is a K3. So K3 is a this value, this one delay, this one 1000 we have here. But here let's see here 100 5200 5200. So this value, okay, let me copy paste and paste here. So this new value will be, if we remove the 0 one time, this will go like this. And after that we can add this one, so we can write this way. Let me add this one, so this will become as a 620. And now we need to multiply this one. So let's see here, calculator I will take. Calculator, we will take normal standard calculator, and now we will multiply this one. 256 into 620 and check here what value we are getting. Let me copy and paste this value here, and what we are getting here, let me check. This value should get a D value. So here, but here in our scenario, let's see here what is the D value. Show IP root Eigrp, this value. Let's see what we get. Some difference we have, but we are near only. Maybe in the calculation we miss somewhere. So this value we will get. Now did everyone is understand this one or having some confusion? See here, what mistake first time what we done, we are saying some of the interface. So by mistake we are adding this one also. First thing is we are adding this one. Let me show you here, this one also. As we told, leaving interface, the outgoing interface. Outgoing means this one and this one. But when we are calculating, we add this one also. So this should not be taken. So the formula what we are using here is 256 into, and let me copy and paste here this formula. Or better, let me write only because if I copy paste maybe it will not come. Let me 1 minute, or let me write down 1 minute. Let me take this pen. What I am saying, as per the Cisco, we have 256 into 10 to power of 7 divided by minimum bandwidth. Okay, and then we have the sum of the interface delay divided by 10, like this. This is a formula. So what we told, 256 into here 10 to power of 7 and divided by the minimum bandwidth. What is the minimum bandwidth? We get 10 to power of 5. So here 10 to power of 5 means this will be cancel, and here we will have 10 to power of 2. So 256 into 10 to power of 2, this will be there, and plus here sum of the delay interface divided by 10. So here what we have here 1 is 100, this side we get 100 and this side we get 5000. So 100 plus 5000. Okay, so when we add this one, what we have, this remains same, 256 into 10 to power of 2, that is nothing but 100, plus this is a 5000. So what is this value? This value is 100, this value is 5000. So what I done, 5000 plus 100 divided by 10. So this should be 5000 divided by 10. So now we can say 5100 and divided by 10. So this will cancel here, so we will have 510, and this is the 100 here, so this should be 600. Here is the 510, so 610, and then we can multiply 256. So then we get this number. What is that number? The one which we are getting here in the, let me show you where is that number. This is that number. Okay, so this way we calculate. Maybe first time we will feel difficulty, just remember this formula. With this formula easily we will get. This is a defined value from the Cisco, and this is a minimum bandwidth. So we will check which one is a minimum. We will write this is a 10,000 is a minimum. We will write that one, and this is a sum of the interface divided by 10. Okay, and just we do the calculation. So this way we will calculate the metric of the Eigrp. So let me stop this recording.